What we're trying to do here is to flip the game that EV charging is not a stress on the electrical grid, it's actually an asset.
Greetings, Earthlings, and welcome back to Earthlings 2.0, the show where we imagine how we could be better versions of ourselves and build a collective future we actually want to live in. In 2022 alone, United States electricity customers experienced an average of 5.6 hours of power disruptions. That works out to be about 1.4 outages per customer, and I bet you can remember which ones you had last year. And as demand for EVs grow, we don't want the proliferation of electric vehicles to be at the detriment of grid stability, especially in areas that have grid constraints. Now, one company says its AI powered fast EV charging solution could enhance grid resilience against power outages while also expanding charging access as EV adoption accelerates. But before we get there, I'm your host, Lisa Ann Pinkerton. I'm the CEO of the award winning PR firm Technica Communications and the founder of Women in Clean Tech and Sustainability. Before building those organizations, I was a former award winning environmental science reporter for NPR and PBS. And I'd like to take a moment to thank you for listening to the show. We love having you here each week, and it is a joy to bring you these stories. And I want to thank you for joining our Substack newsletter and responding to our listener survey and hitting us up on social media and engaging with our posts and sharing them around. Thank you so much for doing all that work because you're helping us get the word out about these great companies and concepts and philosophies that we talk about on the show out to broader people. And that's really what this show is about. So thank you for supporting us there. And if you're feeling so inclined, you can actually support us financially as well for as little as $5 a month. I sound like I'm doing an NPR pledge drive right now, but seriously, as little as $5 a month, you can be a financial supporter of the show and help us continue the great work that the entire team is doing here at Earthlings 2.0. And thank you to Resource Labs for having us on the network. Today's tech spotlight is with the company ElectricFish. Their ultra-fast EV charging product can also serve as an energy storage system and supply backup power during grid outages or, times when the grid is just stressed and needs a little bit more flexibility. Our guest today is Anurag Kamal. He's the co-founder and CEO of ElectricFish. He has a background in mechanical engineering and expertise in battery systems, and he previously worked at BMW and the Oak Ridge National Laboratory, focusing on lithium-ion battery research. Anurag, it's a pleasure to have you on the show. Welcome.
Thank you for having me, Lisa.
The first question I'm going to ask you is, I think it's on everybody's mind. What is the meaning behind the name Electric Fish?
But back when we started, my motivation was to name the company um, after nature or something which occurs in the nature. And electric eels is what I got inspired with. Electric eels can store energy in their organic bodies, and they can dump electricity really quickly, either to protect themselves or to kill their prey. And it kind of really embodies what we're doing here at Electric Fish. The products which we make, the fish which we make, is a distributed energy asset, a DER, a big battery which can store energy like an electric eel. It can also dump it really quickly to charge electric cars, around 20 miles of range in 10 minutes. And also, it's always connected to the grid. And, there are some stories around, or there are some facts around electric eels not actually being eels, they're actually catfishes. So, electric fish. It's electric catfish.
I like the word electric fish better than electric eel for a company name. So kudos for modifying that there. And it makes a lot of sense now. It'll be easier for folks to remember what you do based on that story. So let's talk about your solution. I prefaced it a little bit in the intro, but tell us exactly how does your ultra-fast EV charging solution work and how is it slightly different than what might be on the market today?
So we set out to build a fastest EV charging experience which there could be, which is almost as is at par with gasoline level refueling. Starting with the stats, we saw that the gasoline refueling you stop for 5 to 6 minutes. Um, they're generally very quick stops, and mostly convenience stores, gas stations are the place where you get fuel, unless it's a fleet where you have your own depot. So we were trying to build a charging experience or a very fast charger which can do those kind of charging rates, which are equivalent to 350 kilowatts, 400 kilowatts of charging. Um, but you are not able to draw that kind of power from an electrical grid, especially at a gas station or a convenience store. If you're near the in the highways or very close to, let's say, a substation, you might be able to draw that kind of power. But especially in the distribution electrical grids, that is low voltage electrical grids coming to our cities, it's very difficult to have that kind of power draw because they're originally not built for it. A gas station has maybe a 20 kilowatt interconnection, and if you want to put a two charging ports, that's 700 kilowatts, 800 kilowatts. Like significantly more, 40 times more. And electrical utilities would not give you an interconnection for that because they will have to do a long-term planning to bring that kind of power there. And hence the rollout of EV charging, fast EV charging, is actually slowing down as compared to accelerating up because um, generally the distribution grids or electrical grids are getting tapped out, right? You put up one fast charger, now you don't have any power available for a bunch of feeders nearby. And what we're trying to do here is to flip the game that EV charging is not a stress on the electrical grid, it's actually an asset. So how we do that is by using a really big battery, 400 kilowatt hour battery, which connects to that 20 kilowatt power which is available at a gas station or a convenience store. And we use that 20 kilowatts of power to slowly charge the batteries up over time and use that stored energy to do very fast EV charging. So based on the current traction, maybe 7 to even 15 or 20 vehicles per day, this battery can sustain those kind of fast EV charging loads. And then because there is a variability or there is some uncertainty on how exactly EV charging is happening. So we build AI tools or optimization tools on top of it to understand when exactly EVs are coming up and how much energy is really available for us to actually transact with the electrical grid. And that is a transaction which actually helps the grid. What we can do is we bid into certain electrical utility programs. Most of the smart utilities have that across the US, and we tell them that this is the amount of capacity which we'll have available in case of a grid stress event. And we actually feed energy into the grid during the stressful events as compared to trying more for power. So uh, if we have enough of these units available in, let's say, state of California, then during the flex alerts in which electric vehicle operators get a message, electric vehicle owners and operators get a message that don't charge your car during this time, there won't need to be a message. It just comes to us and we dispatch the power back. Definitely, there are a few variables to pull in terms of like the charging rate or like the rate of charging, like how much price you charge per kilowatt hour to take like change the demand slightly. But that's how we flip the game of EV charging not being in stress, but actually an asset on the electrical grid.
Okay, so does that mean you have like a bidirectional functionality within your charger and the batteries, the energy storage?
It's truly bidirectional, not just the interconnection with the grid. It actually can do V2G as well. So it can take energy from a vehicle too. And that use case is for electric school buses, which have significant amount of battery available and they can come plug in and actually help out a building or whatever local loads they're connecting in. So yes, while our power electronic stack is truly bidirectional in every direction and you can do all kind of power flows at the same time, that's kind of our IP as well. Um, um, but we just need software updates to enable different vehicles or different kind of services.
Are there other companies that also do that, or is yours one of the first?
So traditionally, it's been with level two or a slower charger, in which you can mobilize a few vehicles to be able to interact with the electrical grid and generate revenue. There are companies based in I think New York region, the Formata Energies of the world, or Rhombus Energy, which was recently acquired by
Hmm.
Borg Warner. These are the companies which have definitely introduced products which are bidirectional, and Highland is one of the electric school buses company which are looking to um, truly unlock the bidirectionality of electric school buses because they're only used during certain part of the time. What do you do when they are not being used? So the technology which exists, we are just doing it on a much more significant scale. Or this was the true vision of the company since the beginning, having this bidirectionality, being able to support the grid. So this is not on our roadmap. The first products which are being launched, they have that capability, um, and hopefully when we are really scaling up the production, that is when these are the key features customers look at to make the decision to which brand to buy.
If you think about how a gas station works, what you don't see at the gas station is the massive tanks that are underneath the ground that hold all the fuel, right? And that's how a car is able to roll up to the pump and fill up its tank within a matter of like 5 minutes, right? Because all of the fuel is right there on site. And the challenge that EVs have had is that you're pulling power, your fuel, if you will, from a pipe that's coming from where it's being generated. And it sounds like to me what you're doing is you're sort of mimicking that setup that current gas stations have, whereas like the battery is the fuel tank that's on the property, and that makes it a lot easier to pull that power faster. Am I correct?
It's an excellent analogy, Lisa. Yeah, um, that's exactly how we are doing it. It's just refilling that electricity stored in those tanks would would be just through the existing power. So you do not really need any infrastructure upgrades. And before you ask, yes, there are plans to put the batteries below the ground. For Porsche was Porsche did a pilot with a company just to do that, and there are some advantages to that, to keeping the battery at right temperature, spending less on the um, thermal like conditioning of the battery to get the longest lives. But the associated cost right now and the commitment which current customers would have to really dig the ground and like install this and really committing to it, that is a big driver of slowing down the adoption as well, right? We want to make it incredibly simple for a customer to just adopt the solution, and if they're not happy with it, or if they're not seeing that they're going to transition to electric, they don't have a very significant capital expense tied with that battery or the asset which they bought. So that's why it's a containerized droppable solution today. But yes, there will be variants potentially much down the line when we can put the batteries inside the car.
Yeah, yeah. Well, like so right now, yeah, it's certainly less expensive to pour a cement pad and hopefully a low carbon cement pad in the future, and place the portable system right there versus digging holes and burying it. Um, so let's get back to your technology a little bit more. You said it was a 400 kilowatt storage capacity, correct?
Yes, kilowatt hours. Yep.
Okay. So, 400 kilowatt hours. Thank you. How much power is that? Like, what would be it equate to so people can have a sense?
A home on average consumes around a kilowatt hour of energy every hour, so it's like a kilowatt, during the day, of course, it's total not 24, it's around 10. But just to keep it simple, a house will draw a kilowatt of power during the day to power its operations, and each of our systems is 400 kilowatt hour energy, but it's connected to the grid at roughly 100 kilowatts. So that means that we can power 100 homes for 4 hours during a complete outage scenario. That's the amount of energy which is stored in the batteries. Of course, you use some efficiencies and you drop it by 10% or something for round trip efficiency. But yeah, yes, the scale which you're talking is 350 homes, which is multiple feeders. Yeah, and you probably plan for 12 hours or 24 hours or so. So it's maybe lesser homes for much many hours, or you just do flex alerts. You don't wait for the outage to happen, right? You avoid an outage situation happening.
Mm-hmm, mm-hmm. But it's not like we're pulling all that power to always fuel the EVs. It's just sort of there as a buffer,
Hmm.
right, with the
Yeah.
grid.
Yep. Exactly.
Okay. And I saw on social media that you recently shipped your first commercial unit. So congratulations on that. Tell us a little bit about that project.
Yeah, thank you. It's been a long time coming. We have been producing units and have been doing multiple pilots in different states, but this is a commercial line, so it operated like a line, you know. We got the dedicated technicians that moved through the stages, and then the unit was shipped out. So much more standardized in terms of documentation, like a new product introduction, NPI, DFM, all of this good stuff. This project or the unit which was shipped actually is deployed in Boston now. Um, I'm really proud of the team that we were able to get that system live in less than 2 hours. It was just phenomenal. You cannot expect something like that to happen. You know, that a DC fast charger, it was shipped and then was deployed at 7 a.m. and then 9 a.m. there was a customer which showed up and we did a charging session for them. It was just surreal, even for me, even if that's what we're trying to do here, you know. Um, but yeah, the system is a part of a much bigger contract through the Department of Defense, is through a subcontractor. So 40 of these units are going to be installed at different bases across the US right now, is my understanding. So first unit is live, is being evaluated for around 3 months. Um, and Yeah, this there are some other customers as well. Generally, the way our sales cycles are working right now is that generally customers are buying 1 to 2 units. They're evaluating it for 3 to 6 months for specific metrics, and then the mass orders are coming up. So this assembly line is supposed to build around 20 units by the end of next year, minimum. It can go slightly bit higher if our customers are really pushing us, and then it goes to roughly 80, and then we diversify multiple different um, multiple different like manufacturing facilities, some here, some in Midwest as well. And while we are at this topic, I'd really like to thank California Energy Commission. They are the ones who basically gave us the grant which funds this facility, you know. So I'm really grateful for CEC to do this work, you know. And then we submitted another grant application recently too for really automating this facility to really ramp much more units just from the same footprint. So fingers crossed on that.
Where did this unit go in Boston? Is it who are the people that you're expecting to use it?
It is a private facility, and that makes our bulk of our customers today as well. Mostly, these are public or fleet operators who have already a fleet of electric vehicles which they want to cater to, and they're not able to get a fast charging solution. Either they're stuck with a level two use case, or they have to go and contract or spend valuable time to go do a charging in a public session. So it is going to be a private use case in which some of the Department of Defense vehicles will come and test interoperability and other milestones of the parasitic load of the system and like the reliability they are being tested.
Okay, and you mentioned you've been doing a lot of pilot projects before this first shipment. So, can you tell me about a pilot project that you've run and what some of the results were from that project?
Yeah, there are a few. The one which I'll talk about is the New York one. It was with the National Park Service. Um, Generally, National Park Service is a good segment for public charging. You know, customers who are coming there, they are environmentally aware, they're driving electric, but also there are significant grid constraint at a national park site in which there is only a little bit of power available to for lights and stuff. And generally, there is some UPS systems, uninterruptible power supply systems, just to keep like the guard tower or an AC working for somebody who's manning that guard tower. Um, but it's very limited grid infrastructure, and there is a need for EV charging. So we did a deployment at Fort Bennett Field in the National Park Service in New York City. Hard to believe there's a national park in Brooklyn, but there is one, you know. Uh, and we went live. We did not have to do any grid upgrades. The permitting process was maybe 25 days, like real days, for when they got the application, when they approved it. Uh, we we because the electrical panel was slightly bit further from where exactly the unit was needed to be installed. That is why we did have some permitting expenses over there in like tens of thousands, which is not in not comparable to an actual fast DC charger, which is going to be in hundreds of thousands, you know. So we got the site upgrades, we dropped the unit, we hooked it up. The activation was 2 to 3 days, and the system was doing public charging sessions. Only got some customers who were very zealot to come there every day. It was a fishing spot, so people will do 10 to 15 minute sessions. Some fleet operators use it too. But the key thing which we achieved over there was to actually do backup energy demonstration as well as feeding energy back to the electrical grid. So during the summer, for 3 months, we were able to respond to electrical utility servers and were able to monetize grid services. And that is a very central part of our business model. Each of these units, which are live under the site, no matter which site is it, public or private charging, will be able to get a percentage of that revenue which the asset can generate by grid services. And this we were also able to demonstrate backup energy use case. So we actually turned off the power to the building and we operated an automatic transfer switch. And the guard tower, the AC building, and around 25 street lights. So as far as you can see around the charger, we powered that up for multiple hours to do the demonstration. And we won an award from Department of Homeland Security for that. So yeah, that was my one of my favorite ones. Of course, the Detroit one was pretty nice as well. We did renewable energy integration, but the New York City one was my favorite pilot in which we can prove out very key points of our business model.
And my last question for you before we go is what you think the electrical grid is going to look like in the future with what you're building at Electric Fish. Like, what do you envision 10, 15 years from now?
Yeah, it's beautiful to imagine that, we are at a time when a massive transformation of the electrical grid is going to happen, right? Almost like in the early 1900s when the grid was actually built for the first time. Now it's time to like rebuild in a completely different way. So I would say there are the three major themes. Of course, first is like renewable energy from oil, gas, and coal. We are moving to nuclear, solar, and wind. I think the 80% of energy from these non-conventional sources to these more renewable sources, if you will, is going to happen. So that transition is of course happening. Second thing is digitization, of course. Electrical utilities understand that. You need to understand how the energy is being used. You need to come up with like very clever platforms because there's enough compute available, and these assets are dispatchable. All of these are not dumb loads anymore. You can control them. So digitization is the second one. But the third one, which a little bit controversial as well, because the existing business models do not work that way, is localization. Electrical grids do not have to be centralized anymore. The new sources, and with this, all these advances in like modern nuclear reactors as well, there's no reason for us to have a centralized grid, which is very vulnerable to all kind of grid failures, like all kind of climate change failures or like different aspects which break our grid apart. We can have small local grids. Like it's not a microgrid, it's kind of like mini grid or something. Like there's not a term which is coined yet, right? But like few feeders being islanded from each other and being operated, they'll have their own generating resource, they'll have their own storage, and they'll have their own consumption resource as well. There's no need for the transmission lines to take power from one state to another or one city to another, right? Because you can that every city can have their own energy, and there needs to be some flexibility. I'm not saying that transmission lines need to be just broken down and they won't exist. I think then there is certain need for transmission power as well to get a wider balance. But if a transmission line breaks down, our power won't be out, and that can only be achieved using localization.
And that's dovetailing with a lot of themes that we're seeing across the 21st century. People want their food to be grown more locally. They want their building materials to be developed from sustainable sources and developed and manufactured locally. Even housing is starting to become, with like a lot of prefab housing companies are setting up shops in different cities and making the homes in the place where they're going to be installed.
Exactly. These trend, yeah, we wrote a Medium article on that. Like localization is the trend, because again, the transportation of any kind of goods that has significant carbon impact as well, right? So you want to eliminate that. You want to get the fresher food which is nearby, and of course, like the global supply chains will exist. They don't need to be completely disrupted, but we can minimize our reliance on it. And whatever is happening in terms of like the trade itself, there is certain trend of localization too. So let's see how this goes. But I think that energy grids being localized is the need of the hour, and people are starting to wake up to it, and slowly uh, there needs to be some very beautiful time, like pilot cases which prove it out, and then that trend will really be.
Okay, perfect. Well, thank you so much for being on the show. Really appreciate it. And for all the work that you're doing in ElectricFish, congratulations for the scale that you're starting to see.
Lisa, thanks a ton, and I really enjoyed this conversation as well. So, thank you
You're
again.
welcome. I enjoyed it too. And Earthlings, we'll see you again on another turn of this beautiful blue green space flower that we call home.